All right, everyone, now that we ran through the acidic environment redox reaction in quite a bit of detail, I'm going to be going through this one a little bit more quickly. In this reaction, we have methanol reacting with permanganate in a basic environment. This is our first step to write out the raw reaction. Our next step is to break it down into two half reactions. And in doing that, we have CH3OH going into CO3 2 minus charge, and MnO4 minus going to MnO4 2 minus. Okay, and now to determine which one is the oxidation and which one is the reduction, we need to remember our oxidation number rules, and by doing that we get an oxidation number of -2 on this carbon here and an oxidation number of +4 on this one here. This is a net gain, therefore this is our oxidation. On this one we have a +7 oxidation number here on that manganese, and then on this one we have a +6. This is a net loss, so that is our reduction half reaction. Now we need to go on to step 3, which is balancing the atoms in our reactions. Let's take this top equation. Looking at it, the carbons are already balanced. In order to balance the oxygens, we are going to put in some waters. So we have CH3OH plus 2 waters goes to CO3 2 minus. And that is good for the oxygens. Now we need to balance out the hydrogens. So in order to do that, really all we need to do is add some hydrogens onto the right-hand side of this reaction. We are going to be adding 8 hydrogens. And now it is balanced. However, we must remember that this is a basic environment and we cannot have free hydrogens floating around. They will be consumed. So in order to compensate for that, we need to be adding the same number of hydroxide ions for every hydrogen ion to both sides of the reaction. That's very important on both sides. So if we do that, we get CH3OH plus 2 waters plus 8 hydroxides on the left goes to CO3 2 minus plus 8 waters, because the 8 hydroxides we add on this side will react with 8 hydrogen to produce 8 waters. All right, now our atoms are balanced out, so the next step that we do is to balance the charges, right? In order to do this, we add electrons. I'm just going to tack them on here. So in this case, in order to balance the charges, we need to add 6 electrons here. And then let's recall our reaction up here, which is already balanced in terms of atoms. And we are going to now balance that in terms of charges. MnO4 minus plus, we need to add an electron on the left to balance it with MnO4 2 minus. Okay, that's great. Now that is balanced in terms of charges. Now we need to use some multiplication factors in order to cancel out these electrons, because we do not like free electrons floating around. Sorry, I forgot to write that in. Okay, so we are going to multiply this one by a factor of 6 so that we can cancel these electrons with these electrons. And in doing so, we get 6 MnO4 minus plus 6 electrons goes to 6 MnO4 2 minus. All right, that is great. I love it. Now we are going to combine our half reactions together, and we are going to get a very, very long reaction, which is the nature of these types of problems. CH3OH plus 2 H2O plus 8 hydroxide ions plus 6 MnO4 minus plus 6 electrons goes to CO3 2 minus plus 8 waters plus 6 electrons plus 6 MnO4 2 minus. I told you it was going to be a long one. Now our final step is to simplify this further, and we can simplify it quite a bit. We can get rid of these 6 electrons on both sides, and we can also totally get rid of these 2 waters over here, which will bump these waters down to 6. And if you look at it, this is really our final reaction, right? And it is totally fine to have 8 hydroxides over here because we are in a basic environment. This was pretty quick. I hope that you guys are able to understand all of the steps. Please reach out with any questions, and good luck on these types of problems.